Okay, so this is Math 103 final exam review. So the first exam we're going to go over is fall 2020 final exam. Okay, so question 1. And again, I advise that if you did this beforehand, and then now we're going over the questions. If you haven't done it and you're watching the recording, I would advise trying to do this first and then looking at the answers. So question 1 says, let f of x equal this function be a probability density function on this interval. So what does it mean to be a probability density function? It means that the integral from negative infinity to infinity of whatever function you have, that should equal 1. This is by definition of what it means to be a probability density. So in our case, notice that our interval is just from 0 to pi over 4. So we don't need to take into account like negative infinity all the way to infinity because our function is only defined on this small interval. So right now, our goal is that we want 1 to equal the integral from 0 to pi over 4 of the function they gave us. So c sine x cosine x dx. This is what we want, and we want to find c. So part A was asking for what is c? Okay, so you look at this integral and you see there's two parts. There's a sine x and a cosine x. That means you can't just take the integral like easily because it's not just like, oh, the integral of sine x cosine x is cosine x or something. You have to use different techniques. So what are the techniques we've learned? Let's try u substitution. So for u sub, let's just pick one of, because they're both trig functions, let's just pick one of them. So say I pick u equals sine x. Then what does du equal? The derivative of sine of x is cosine x dx. And look how that worked out. If we plug in this u for sine of x, what's left over, this cosine x dx, is exactly du. That's exactly what we wanted. So right now I'm just solving this integral. I'm going to take the c, the constant, and move it out just for clearness. And we're doing the integral of 0 to pi over 4 of, we're substituting sine of x for u. And what is cosine x dx? That's du. So now we have the integral of u. What's the integral of u? You add 1 to the exponent, so it becomes 2, and divide by that exponent. And we're evaluating from 0 to pi over 4. But we don't want our answer in terms of u. We want it in terms of x, so don't forget to resubstitute that u back in. What was u? It was sine of x squared over 2, 0 to pi over 4. Now we have to evaluate this at pi over 4, then minus, evaluate it at 0. So what do you get when you substitute in pi over 4? So you have sine of pi over 4 squared over 2 minus, you plug in 0. So plugging in 0 gives sine 0 squared over 2. And what does that give you? Sine of pi over 4 is square root 2 over 2, all squared, divided by 2, minus, what is sine of 0? That's 0 over 2. How did I know what sine of pi over 4 and sine of 0 are? You should remember the unit circle. And that should tell you, so you look at what angle it is and what the y value is. Okay, so we keep simplifying, and that gives 2 over 4 over 2. This is minus 0, so we don't care about that. And this is, so this is 2 over 8, or c times 1 over 4. So what was the whole goal, remember? We wanted 1 to equal this integral. We just found that that integral is c times 1/4. So remember, we wanted 1 equals c times 1/4. So now we solve for c. C equals 4. any questions on part A? Okay, part B. So part B is asking, find the median of this probability distribution. Okay, so remember our whole distribution from part A, we had this whole thing from 0 to pi over 4 of our function. But right now we're finding the median. So the median is you want to find m, some number such that, and now we can choose either way. We can either do some number median to pi over 4, this equals a half. Or if you wanted to do the other way, you could do from the lowest bound. So usually this is like negative infinity to m. But in this case, because our interval is only defined on 0 to pi over 4, that's why we're making this 0, our lower bound, to m of c, which now we know is 4 of sine cosine dx equals 1/2. So we could do either one, doesn't matter. So let's choose, I'm just going to do the first one. If you did the second one, you should still get the same answer anyway. So what is the first one? Let's evaluate this integral for sine x cosine x dx. So now, because we already figured out this integral, I'm just going to move a bit faster. How did we evaluate it? We chose u equals sine x, du equals cosine x dx. So this becomes 4 times integral m to pi over 4 of u du, which is 4 times u squared over 2, or 4 times sine of x squared over 2 from m to pi over 4. And now we can actually plug in these values. What is sine of pi over 4? That's square root 2 over 2 minus plug in m. So sine of m squared over 2. So we found that this integral is this whole thing. And we want to set that equal to 1/2. So we want to equal to 1/2. This is what we want. What does that mean for us? Well, okay, maybe let's keep simplifying like this part so we can write it nicer. So let me like move this down. Add another page. Okay, so what is this? This is 4 times, this is 2 over 4 over 2 minus sine of m squared over 2. Okay. And that is 1 minus sine of m squared over 2. So this is what we want. We want that to equal 1/2 in order to find m, our median. So now we evaluate, we solve for m. So how do we solve for m? You can subtract 1 on both sides to get, so solve for m. You get negative 1/2 equals this negative sine m squared over 2. Divide both sides by half to get half, or divide by negative sign, sorry, to get half equals sine m squared over 2. Now you can multiply both sides by 2 so that you get, wait. Sorry, this should be 2 over here. So here, this simplified to 1, but this minus, this would cancel out. This would be a 1 and you'd have a 2 multiplied. Okay, so sorry about that. This would be 2 and 2. Okay, so now we divide both sides by 2 and we get 1/4 equals sine m squared. Now when we square root it, don't forget there's a plus minus when we square root something. When is sine of, for what m do you get sine of m equals 1/4? Well, you can think about the unit circle again, where, oh, sorry, wait. Oh, yeah. Sorry, when you square root it, yes, you get plus minus 1/2. Thank you. And where is y value 1/2? That's around like here. or here, these orange points, and this is pi over 6, 5 pi over 6. We write it so that's like 5 pi over 6. So we get m equals pi over 6 or 5 pi over 6. But remember what our interval was. Our interval was from 0 to pi over 4. So this pi over 6 is out of our bounds. We don't want that. So right now, our answer for m is pi over 6. And that's your median. Any questions on part B? Okay, part C.
Wait, I have a question.
Part C was find the, yes, go ahead.
When we were, so we wanted a 1/2, right?
Yes.
How did we get rid of the 2 under the 2 over 4 and sine m squared?
Here, yes. So this was me simplifying everything. So you can, if you want, you can write it out a little bit more. Here you have 4 times, this is 2 over 4 times a half, right? Minus sine of m squared over 2. So this gives you 4 times 2 over 4 times 1/2. So let me write this 4 minus 4 times this sine of m squared over 2. Over here, the 2's cancel and the 4's cancel. So you're left with 1 minus, over here, you also get this cancellation, 2 sine m squared.
Got it. Thank you.
Yep. Any other questions on this part? Okay, so the median was pi over 6. Now, part C says find the mean. So what is the formula for mean? Your mean is always your integral from, okay, so this is in general, from negative infinity to infinity of x f of x dx. Right now, our interval is limited. Our interval is from 0 to pi over 4. We have an x, and we times what was our function that we found. Our function with the c that we found from part A plugged in is 4 sine of x cosine of x dx. Now, when we found the integral of just 4 sine of x cosine x, that was fine. We used u substitution. But right now, if you try to use u substitution, like what would you choose as u? If you choose u as a trig thing, then sure, you get the other trig thing, but what about this leftover x? So u substitution here is not would not work. The correct choice you should use is integration by parts. Integration by parts. Okay, so what do you choose as u? According to integration by parts, we follow Liate. So are there any logs? No. Any inverse? No. Algebraic? Yes. We see a polynomial, which is x. So we're going to choose u equals x. This is our u. Everything else is dv. So dv equals this 4 sine x cosine x. Okay. Let me actually simplify this better. Let me put the 4 outside so we don't have to deal with that random 4. And we're going to do the integral of sine x cosine x. So still the same thing. Let's just focus on this highlighted integral. So we have u equals x and our dv equals sine of x cosine x. Okay, so then du equals what? Dx. dv, now we're doing the, how do you find v? We do the integral of sine x cosine x. Does anyone know how we would find this integral? Yes, use substitution. And we did the exact, we already found this integral, in fact. We found it when we were doing all of our work for like part B and part A. The integral of sine of x cosine x is sine x squared over 2. So I'm going to take that result and say that this integral is sine x squared over 2. And you can recheck it if you want. Okay, so now we can follow our formula. Integral of u dv equals uv minus integral v du. We plug in our parts. So plugging in u, plugging in v, minus, plug in v, x, and plug in du, which is this. Okay. So now at this point, our question is, what is this integral? Like sine of x squared over 2. You could try u substitution maybe. If we choose u equals sine x, but then that would give us a derivative of cosine x. We don't have anything left over here that's of like cosine x. Can we do integration by parts? Well, that also wouldn't help us too much. Like what do you choose for u, or what do you choose for dv? You would still end up needing to take the integral of something that we also don't know how to take the integral of. So it turns out that in this question, I guess they were assuming that you wrote down all the trig properties maybe, but remember from the double angle properties that cosine of 2 theta equals 1 minus 2 sine squared theta. So from this, we know if we simplify it, cosine of 2 theta, subtract 1 on both sides equals negative 2 sine squared theta, and then you divide by negative 2 on both sides, which gives you that sine squared theta equals 1, okay, cosine of 2 theta minus 1 over negative 2. Or you could also write it as 1 minus cosine 2 theta over 2. So this was the fact that you needed to use in order to solve this integral. Okay, so from that, we can continue our work. So this left-hand part, I'm just gonna keep writing the same exact thing. But now, what is this integral? So let's take out, I'm gonna take out the 1/2. And we're doing integral of sine x squared. What did we just find sine x squared is? It's this, 1 minus cosine 2x over 2 dx. Now this looks like a much better integral to solve. Why? Because now we just have one trig. So when you see one trig with something complicated in here, it's most likely that the complicated thing is what you're going to choose for u. So that's a hint that, oh, we're going to use u substitution for this. Okay, so we continue this left side. I will copy and paste. Now we have the integral of, okay, I'm also going to take this 1/2 and move it out so that we have a minus 1/4 of this integral, 1 minus cosine 2x dx. Okay, because this is just this whole thing times 1/2. So I'm taking that scalar out, so it's 1/4. Now let's focus on this integral. So I said, let's try u substitution. We choose u equals 2x, so du equals 2 dx, or 1/2 du equals dx. Okay, so where is here? Okay, so how does that help us? So we have this left integral again, minus 1/4 of integral. So when you have integral of one function minus another function, you can separate it. So I'm going to do integral of the first function plus, or so this distributes. This is minus 1/4 of this plus 1/4, or okay, let's do a big parentheses, minus integral of cosine 2x dx. Wait. Yes. Okay, but okay, so let's move this down. First, I'm just going to separate these two functions. So I'm just rewriting this integral minus this integral. Okay, now I'm going to do use substitution. So we have this again minus okay, minus 1/4 times this integral plus 1/4. Wait, something seems okay, no, never mind. It seems correct. Yes, minus 1/4 that plus 1/4 cosine 2x dx. Okay, now let's do use substitution. So that whole part was just me like rewriting things so that they were like distributed. Okay, so now we have this minus, what is the integral of 1? That's x. And what about this integral of cosine 2x? So use substitution. Let's replace that with our u times what is dx? Dx is 1/2 du. So we get this thing minus 1/4 x plus 1/8 of, what's the integral of cosine? It's negative sine of u. But what was u? U was 2x. So right now we have that our integral is this thing minus 1/4 x plus, minus 1/8 sine of 2x. Oh, sorry, the integral of cosine x is not negative sine x, it's positive sine x. Okay, any questions about this, getting to this integral part? Yeah. Yes. Okay, so we just found that this highlighted part equals our highlighted part. And then now, yeah, don't forget the 4. So let's do the 4 at the end though, because let's focus on this highlighted part. So the highlighted part, we found that integral, but we have to evaluate at the bounds. So at the bounds of 0 to pi over 4, what does that give you? That gives you, so plug in pi over 4 first. Pi over 4, sine of pi over 4 is square root 2 over 2 squared over 2 minus 1/4 times pi over 4 plus 1/8 times sine of pi over 2 is 1. So 1. So that's plugging in pi over 4 minus plug in 0. So when you plug in 0, you get 0 minus 0 plus 0. And you can, so this simplifies to pi over 4 times, so pi over 4 times 2 over 4 over 2 minus pi over 16 plus 1 over 8 minus 0, which equals, these cancel out and you get pi over 16 minus pi over 16 plus 1/8. So you get 1/8. That's that's our highlighted integral evaluated at the bounds. Okay, but remember our original question. So let's go back to our original question. It was finding this 4 times that integral. So our mean is 4 times. We just found that integral evaluates to 1/8. So this answer is 1/2. Okay, any questions on this part?
So are we expected to know the double angle and the half angle formulas for the final?
Yeah, you should. So I also, okay, they're not in this one. They're in my solutions and they're also in yesterday's recitation notes, this page. Yeah, double angles are over here. Okay, any other questions? Yeah. Mhm. Yes. Yeah. Okay, so this part I'm focusing mainly on this integral of cosine 2x. So how do you find the integral of cosine 2x? You have to use u substitution. So I choose u equals 2x, and I take the derivative, you get du equals 2 dx. Then divide both sides by 2 because all that's left over is the dx. So all we want over here is dx, and which we find it's 1/2 du. Now we do the substituting part. So we have cosine of this 2x was our u, so I plug in u. And this dx we just found is 1/2 du. So I'm going to put the 1/2 du there. Now, what is the integral of cosine? So I move this 1/2 out. So that's how I get 1/8. Integral of cosine u is sine of u. But what was u? We don't want u's in our actual final answer. So u was 2x. So that's why I re-put in 2x here. And so this integral is 1/2 or 1/8 sine 2x. Because we don't want our answers in terms of u's. The u substitution and putting everything in terms of u's and du's, that was to help simplify our integrals so that we could take it more easily. Okay, any other questions on this part? Okay, so let's do question 2. Okay, how many questions are in? 6. Okay. Oh, I would like to say I did not end up getting question 4. So yeah. Okay, let's just keep continuing. Question 2. So we have this function. Okay, wait. Okay, I guess 2020 is important. Okay, we'll focus mainly on this one. So we have our h of t equals e to the negative 2t squared minus t. We want to find where is it increasing and decreasing. So step 1, we're finding where it's increasing, decreasing. And while we're at it, you should also find the relative max and mins, because that's like the next step that makes sense. So how do you find increasing and decreasing? We need to know the critical points. So how do you find the critical points? We need to find the derivative, of course. What is the derivative of e to this complicated thing? Well, if you say that it's e to the negative 2t squared minus t, that is not correct because you have this complicated thing in the exponent. So you have to use chain rule. Chain rule says you do the derivative of your outer function, which is e to this thing, but then you have to multiply by the derivative of your inner thing or your complicated thing. So the derivative of negative 2t squared minus t, what is that? That's 4t minus 1. So this is your derivative. Now for your critical points, you want to find where your derivative equals 0. Where does it equal 0? Well, we have our derivative, set it equal to 0. This gives us either this part equals 0, but that never happens because e to any number will always give you a positive number. So never gives you 0. So we don't have to worry about this. We need to worry about this part. Negative 4t minus 1 equals 0. If you add 1 on both sides, then divide by negative 4, that gives you t equals negative 1/4. So that's one of your critical points.
Do you have to sketch a graph for this question?
Yes, it says sketch a graph. I did not sketch a graph, but you can sketch a graph. Yeah.
So why did you like split it up, like when you're finding which part
We can't hear you.
All right, so can people on Zoom hear me now? Am I back? All right. So yeah, so you can only keep in mind that you can only do this where you're like separating this first thing equals 0, this second thing equals 0, if you're multiplying things, because that's what it means for something to equal 0. Like this first part equals 0, this second part equals 0. So whenever you're encountered with like finding the critical points, that's also a very good idea to try to put it in some, like if you had some really like this, if you were given this as your derivative, this thing in purple, and you wanted to find the critical points, you should immediately think, oh, this first term has an e to the this. This second term also has an e to the this. That's good. So we can factor that out, and we would factor it out like so. And then now you can find your critical points. So if you ever see terms that have something similar, you want to think about factoring that out. Okay, let me move that over here. Oh. Okay, so we just found our critical point is t equals -1/4. Now, how do we find where it's increasing, decreasing, or where the relative max mins are? We have to create our sign chart. So sign chart using your derivative. When I say using the derivative, I mean like the points that you're going to plug in are going to be plugged into the derivative. So in our sign chart, we only have -1/4. Over here, let's try plugging in a point that's smaller than -1/4. So let's try -1. What do you get? You get e to something, we don't care because that's always positive, as I said. Then -4 times -1 minus 1. What does that give you? That gives you e to the number times 4 minus 1, which is e to the number times 3, which is a positive number. That's what we care about. Is it positive or negative? On the right side, let's try like the easiest one you can think of, 0. When you plug in 0, you get e to something times 0 minus 1. So that's a negative number. This tells you that your answer is, so increasing from -infinity to -1/4, because that's where it's positive here, and decreasing from -1/4 to infinity, because that's where it's negative. That's where your slope is negative, so it's decreasing. And now you can imagine the graph. If your slope is like increasing here and decreasing, that gives you a maximum. So we have a max at x equals -1/4. Any questions on that part? Okay, so then we need to find, let's look at concavity and like inflection points. So if there's a question like asking literally every single thing, this is the exact algorithm you want to follow. It's always the same process, no matter what. So you want to find your concavity. So what do we need for that? We need the second derivative. So remember what was our first derivative? Let me copy that. Our first derivative was this. What is our second derivative then? Our second derivative is, how do you take the derivative of that? You need to use product rule because you have this first orange thing times the second blue thing. So product rule says you do the first term times the derivative of your second term. I'm gonna keep it as like derivative of your second term like this, so that we don't get too confused. Plus a second term times derivative of your first term. Okay, so we have this first term. What's the derivative of -4t minus 1? It's -4. Plus this second term, what's the derivative of the orange thing? Don't forget you need to use chain rule for this. -4t minus 1. Now for your second derivative sign chart, we want to set the second derivative equal to 0 in order to find our points. So if we set our second derivative equal to 0, well, what did I just mention about how you find the roots? You notice something similar here, this e of t, this e of t. So we want to factor that out. So we're left with -4 plus -4t minus 1 squared. This equals 0. Now we have the first thing and times the second thing equals 0. How do you find the roots? You set this thing equal to 0, which again never happens because e to anything is always positive. And then we set this thing equal to 0. So we set this equal to 0. Okay, so I will let you simplify that, and we end up getting t equals, so, okay, let me write out a little bit more steps. You should simplify this. You will get that it's equal to 16t squared plus 8t minus 3. And then you can either, if you know how to factor it, or use the quadratic formula. So quadratic formula, and you'll get that t equals 1/4 and -3/4. So since we're low on time, I'll let you guys work that out. Now, our points are 1/4 and -3/4. So let's make our sign chart. We have -3/4, 1/4. On the left, we can try -1 maybe, and we see that what is the part that's important? This 16t squared plus 8t minus 3 part is important. So we would get 16 minus 8 minus 3, which is a positive number, so plus. And you do the same things over here and here, you'll get negative sign plus sign. What does this tell us? It tells us that we are concave up at -infinity to -3/4 and 1/4 to infinity, because that's where we have plus signs. And we're concave down at -3/4 to 1/4, because that's where our negative sign is. And if it asks, because our sign changes at -3/4 and 1/4, we know that our inflection points are at x equals -3/4 and 1/4. Okay, any questions on this? Yeah,
You plug back into your
second derivative,
second.
yes. So, yes. Sign chart using f double prime.
Instead of doing quadratic formula,
Mhm.
can you just add 4 and then take the square root of 4 and make 2 separate equations?
Yeah, like the squaring root technique, or
Yeah.
yeah, like so that it's a perfect square. Yeah, you
Or
could
just add 4 to the other side, take the square root, then you get negative 14 minus 1. And then
Wait, add. So you're adding 4.
like don't even like FOIL it out. Just keep
Oh, I see. You have this equals 4, then square root it. Which gives you plus minus 2. So negative 4t equals plus minus 2 plus 1. Or t equals plus minus 2 plus 1 over negative 4. So you get, yeah, also works. Wait, negative 2. Yes, it also works. Yeah, any other questions? Let me put this in my glue. Okay. Okay, let's do question 3. Okay, so question 3. We want to build a right triangle that's inscribed under this parabola like shape. So for these, like, this is an optimization problem. We need to write, what are we given? So we're given that y equals 9 minus x squared. Okay, we're gonna end up needing to use this length here, like this x. So let's just call this, I'm gonna call it the orange x. And I'm gonna call this height a purple y. So given, I drew x here, as you see, and I drew y. And what about this point, this red point? Well, they gave us the formula. It equals 9 minus x squared for some x. So let's write down y equals 9 minus x squared. Now, what is the question asking for? It's asking for us to maximize the area of our triangle. So whatever it's asking you to maximize, that's the formula you want to use. So it's asking us to maximize area of our triangle, which I drew a little triangle. What is the area of a triangle? So A, right now we have it in terms of x, y. Area of normal triangle is half base height. In this case, our base, I named it x, and our height, I named it y. But this is an equation in terms of 2 variables. That would be multivariable calculus. We don't want 2 variables. We only want 1 variable. So how do we get rid of one of the variables? Well, they told us that y equals 9 minus x squared. So we can substitute that in. So I'm going to substitute so that we get our equation just in terms of 1 variable x. So it's 1/2 times x and times, what is our y? They told us it's 9 minus x squared. So this is our equation right now. This, let me like distribute 9/2 x minus 1/2 x cubed. This is our function right now. Okay, but what's the goal of this? We're trying to optimize. So optimization definitely need like a derivative of something. So we're gonna take the derivative of our function right now. The derivative of a of x is 9/2 minus 3/2 x squared. Just following the normal derivative rule or the usual one. And we need our critical points because our critical points tell us when we might have a max or min or a relative extrema. So we want to set our first derivative equal to 0. What does that mean for us? Well, if you solve, so subtract 9/2 on both sides, multiply by -2/3 on both sides, so you get 3. So x equals plus minus square root 3. But note that we don't want negatives, because how can you have a negative length, right? So our critical point is just x equals positive square root 3. That's our candidate right now. Okay, so we just found if it says like you don't so in past quiz problems, it was like, you don't, for time, you don't need to prove it, then you could just stop here, x equals square root 3. But just for completion, let me do the check. So how can you check that it's a max? Well, you can do two ways. Either use the first derivative test, or you can use the second derivative test. For the first derivative test, we already know it's the derivative. Remember that a prime of x is 9/2 minus 3/2 x squared. And you can make your sign chart and plug in points to your derivative, and you'll get a plus and minus. So you have an increasing slope, decreasing slope. Yes, it is a maximum. So first derivative test confirms that your x equals square root 3 is indeed a maximum. Second derivative test, you would need to find the second derivative, which is 3x negative 3x. And what you do is you plug in that critical point. And depending on what sign you get, we got a negative sign. That means it's concave down, so it looks like a frown. And that is indeed a maximum also. So either test confirms it. Either one works. So, oh, and also to actually answer the question, find the dimensions. So we found x equals square root 3, but what is y? Well, y was, by the formula they gave us, 9 minus x squared, which when you plug in what we just found for x, you get 6. So the dimensions are square root 3 by 6, which gives an area of 3 square root 3. Any questions on this example or this problem? Yeah. If they don't say like you know how on the quiz it said like for time you don't have to prove it, then you don't need this part. But if it doesn't say anything about it, it's assuming that you should check it. Any other questions? All right, so yeah, number 4 I did not get. I don't know what it's asking for. So please ask Rimmer. Okay, let's do number 5. All right, so number 5. Okay, you see an improper integral. The first thing you think is, oh, let's use the formula for what do we do for an improper integral, right? So let's focus on I1 first. You could do it by, so we have this integral, this very, very long integral. Maybe, okay, wait. Let me show my solution so I don't have to keep writing this. Okay. You could write, what do we do? We could, first I like distributed it so that it's simplified out. And then because it's a function plus a function plus a function, I take the integral of each of those functions, which I colored in red, orange, and purple. Then you would have to find this integral. How do you find this integral? Well, we could use that like limit rule where we do the limit of b going to infinity and we replace, where was that infinity? It was up here, so I put the b here. You could evaluate those integrals, etc., get your answers. You could do each part. However, once you get the red one's okay. Once you do the orange one, this integral, it turns out to be very, very long if you did tabular integration. So you see, I did not continue writing it out. You could also try with the purple one. You'd also run into the same issue. If actually evaluating these integrals would take like too much, like very long time. So there must be a different way that this question is asking you to solve it. So we're not going to be actually taking the limit of this integral, finding the integral, etc. That's too much work. Instead, this is a clue that we should use the comparison test. So how would we do the comparison test? Well, for the first one, so we have this first integral, we want to find something to compare it to. What looks familiar? Maybe this like e to the negative x looks familiar because we know those rules, remember? So recall from yesterday's review session, I will copy paste this here. Recall we know these nice rules, like the types of integrals and their conditions for convergence. So let's choose, I'm going to choose our familiar function, g of x. I'm going to make it e to the negative x because that's familiar. We know that g of x converges because -1, this exponent -1, is indeed less than 0. So g of x converges here. Now, comparison test says we have to check, is f of x less than or equal to g of x, question mark? Well, if we copy f of x here, is that less than g of x? Well, here you'd have like a number plus a number plus another number. So this is probably going to be either 1 or greater than 1. So it's not less than e to the negative x. This is not true. But this question I think was a good example because here, okay, we chose a specific g of x that converges, but it didn't happen that f of x is less than g of x. What if we choose something else for g of x so that this inequality is held? Like we want something over as g of x so that this inequality is held. What if we choose instead, like for example, g of x equals like 100 e to the negative x or something? Then for certain x, this is f of x will be less than g of x. This is true. So right now we got that our g of x, and by the way, this still converges because you're just multiplying by a scalar. We got that it converges, f of x is less than or equal to g of x. So by comparison test, our difficult integral, which was I1, let me just write I1, converges. Any questions on this first I1? Yeah, Tom.
How did you figure out that, like, what would be inside the parentheses on the left side of the, like, that would be like just some like small number?
Oh, because so cosine of anything is always going to be between 0 and 1. So even if you chose x equals 0, then you get 1 plus 0 to the 9th plus 1. So that's going to be greater than 1. Greater than 1. Even if you chose x equals like pi over 2 or something, you get 1 plus something plus 0. It's still greater than 1. So yes. Any other questions?
If you
Yeah.
chose like 1,000 for x,
Uh-huh.
then you would have like 1,000 to the 9, and that,
Then yes, this g of x specifically wouldn't work.
okay.
But for a certain g of x, so you could choose g of x is like 1,000,000 e to the negative x. I was just choosing 100 as an example to show that this in fact will hold.
Are we able to just pick like any scalar?
Yes, only scalars. So make sure look at scalars. Yes. There's a very nice example in Paul's online calculus notes, by the way. So you can also look that up.
Comparison test.
Yeah. So search up like Paul's online calculus notes, comparison test improper integral. There's a really nice example he did with, I think it was y to -1 over like x or something. And he chose y something over 4 so that like the scalars would work out. That was a good example. Any other questions on I1?
Wait, so we can pick any scalar?
Yes. If you find that, like we found that it converges and we wanted this to hold, So if we multiply by some scalar so that this can hold, then that's fine. But even if we pick any scalar and it didn't hold, then that means you probably did not choose the correct g of x.
I don't really understand how you know that the like 100 to the 9th, that part, how do you know it'll be smaller than 100 times e to the negative x?
Yeah, so like if you chose like x equals 0, on the left you get 1 plus 0 to 9th plus 1 times e to the 0. Is that less than e to the 100 e to the 0? Well, here you have 2 times e to the 0 is 1. Is that less than 100? Yes. Does that make sense?
Okay, yeah, that makes sense. Sorry.
Okay. So, yeah.
Yeah, this question's kind of similar, but why didn't you apply the other side by 100?
Multiply the other side because this f of x is already set. We can't change anything to f of x.
So we can only change the other.
Yes, because g of x, we're choosing some function to compare it to. So we can choose anything we want for g of x, but this f of x you can't change. Like it's fixed there. Okay, so let's do I2 just so we get a little bit more. So these look very similar, right? You should notice immediately, or not immediately, but soon, that what is like the difference between these? The difference is their bounds. I1 was from 0 to infinity. That was nice. We just found that it does converge. What about I2? The only difference now is that we're going from negative infinity to 0. So let's look at from negative infinity to 0. So I2 equals negative infinity to 0. So your first guess is that, okay, let's again choose g of x equals e to the negative x. And you say that converges because of our rules that we recalled. But here you want to be careful that our rules above that we recalled from yesterday, these are specifically the integral from some number b to infinity of e to the kx that converged when k is less than 0. But when you flip the bounds, this same rule doesn't hold anymore. Why? Because I will prove it. So if you were going to look at the integral of e to negative x from, what are we doing now? Our bounds are negative infinity to 0. So we chose g of x equals this. We want to find out, does it converge or diverge? So how would you do this? You can use the normal limit or improper integral rule, or you do limit from a to 0 of e to the negative x dx. That gives you the limit of a to the negative infinity of, what is this integral here? You can use substitution. I would just say it's negative e to the negative x from a to 0. Then you plug in 0. So you get negative e to 0 minus, you plug in a. So what does this give you? Gives you e to the 0 is 1. This is plus e to the negative a. Now, what is the limit as a goes to negative infinity of e to the negative a? You can imagine like drawing the graph of e to the negative a. It looks something like this. So as a goes to negative infinity, this diverges. There's no limit here. So this whole thing diverges. Does not exist. Because the limit as a goes to negative infinity of e to the negative a diverges, keeps on going, doesn't stop. So what we chose, our g of x equals, actually diverges. And now we do what does the comparison test say? Our familiar thing diverges. We want to check, is f of x greater than or equal to g of x? Well, now we can see that if we keep just the normal rule, we said before that this is always going to be greater than 1, because no matter what you plug in, even if you plug in x equals 0 or x equals 1, whatever, this will always be greater than 1. So you're multiplying like a number greater than 1 by this e to the negative x, it's gonna have to be greater than e to the negative x. So this is true. So by comparison test, our I2 diverges. Yes, converges. Any questions on I2?
So when we're doing the comparison test, we should always just, like, when we pick our g of x, we just have to prove that either diverges or converges first.
Yes, you should.
And then
And then make sure the condition is met. And then if that condition is met, then your unknown does whatever your g of x does. And now, instead of like proving this thingy, you could also use asymptotic like inequalities thing, which we did in example yesterday.
so since we said that g of x can diverges, doesn't
Oh, sorry, diverges. Yeah, I wrote converges. I2 also diverges.
How do you know that you're picking the right g of x?
So g of x should be something that looks familiar in here. And it should be something that you can find if it converges or diverges. So usually if you see an e to the something, you should pick that, because we know all the like converging rules that we recalled. And even if we don't, e to the something x, we can take the integral of that more quickly, as opposed to if it was like x to like something complicated. So you should pick, like x to, there's maybe an x to 9th here, but this is like all together. So what's the other thing that looks more simple, like e to the negative x? So we choose that, and we know if that converges or diverges by figuring it out.
So because the bounds were different, the times of use the improper interval.
Yes. For last time, for like I1, when we were doing the bounds from 0 to infinity, we could have also done out this whole thing, like found the improper integral, etc. But we already knew the rule, so we don't have to waste our time doing that. Any other questions on I2? Okay, so what is I3? I3 is this whole thing again, but now the bounds are from negative infinity to infinity. What are the rules for when the bounds are negative infinity to infinity? We have to split it up into like, that's why they worded the question like it was. They gave us, we're finding I1 from 0 to infinity, then I2 is negative infinity to 0. So that's a clue to us that we should split this integral up into this first thing plus integral from 0 to infinity of the same thing. Now, what is this first integral? That was I3, which diverged. What is the second integral? That was I1, or sorry, this was I2. This one was I1, which converged. But imagine if you're adding like a super infinity, like super big number with some smaller number, it's still gonna overall diverge. So your answer for I3 is also diverge. Any questions on I3? Well, if you have like a diverge plus a converge, well, like think about like a billion plus 1. It's gonna be a billion still. So the diverge will overwhelm it. Any other questions on I3? Oh, sorry. So many final grades coming out. Okay, so number 6. All right, number 6 I will say was quite tricky-ish. Okay, well actually once you figure, okay, the first thing I was trying to figure out first was, what does it mean for something to be asymptotically equal, right? This little notation thing. It means that your limit as x approaches infinity of, you pick one thing over your other thing, should equal 1. That's by definition of what it means to be asymptotically equal. But specifically, why do they say, like, why do they add this weird, like, at 0 thing? So you might think, like, are we plugging in 0? Well, but that wouldn't make sense, because if you plugged in 0, you get 0 in the denominator. That doesn't make sense, right? So, but what is this 0 is significant because it tells you what you're actually going to do. So this, when you have like a function is asymptotic to a function at some point, that means that, so function f asymptotically equal to some other function at point B means you should do the limit as x approaches that point B that you were given of f of x over g of x should equal 1. So now this is what we want to follow. So we want our limit as x approaches, what is the point they gave us? 0. F of x is, let me write out this f of x. And our g of x, they tell us it's ax squared. So we want this to equal 1. So now let's evaluate this limit. So what do you do when you're approached with a limit? The first thing you do is plug in x equals 0, right? Plug in x equals 0. What happens? You get 1 plus 0 minus 1 minus 0 over 0, which is 1 minus 1 over 0, or 0 over 0, indeterminate. That tells you you want to use L'Hopital's rule. So let's use L'Hopital's rule. Take the derivative of the top. What is the derivative of this highlighted part? Square root 1 plus 2x. You can think of it as 1 plus 2x to the 1/2. That way we can use the chain rule for finding that derivative. So you bring the exponent down 1/2, keep the inside the same. Exponent of is 1/2 minus 1, so that gives you -1/2. But then chain rule, you have to multiply by whatever complicated thing is inside here. So that's 2. Then derivative of 1 is 0. Derivative of negative x is 1, -1. And what about the derivative of the bottom? That's 2ax. So let me just simplify that a bit. These 2's cancel out. We're left with 1 plus 2x to the -1/2 minus 1 over 2ax. Just re-simplified it. Now let's try plugging in 0 again. Maybe it will work this time. We try plugging in 0, we get 1 to the -1/2 minus 1 over 2 times 0, which gives you 0 over 0 again. So let's try using L'Hopital's rule again. Derivative of the top is now, so we bring the exponent down, -1/2. The new exponent is -1/2 minus 1, so that's -3/2. And multiply by the derivative of the inside, which is 2. All over, what is the derivative of 2ax? 2a, remember, a is a constant. So you have constant times x. That derivative is just a constant. Now let me simplify things. So crossed out the 2's so that we're left with this limit of -1 plus 2x to the -3/2 over 2a. simplify. Yeah. So yes. So I was trying to because this is 1/2 times 2, so it becomes -1. Okay, so now let's try plugging in x equals 0 again and see if we finally get something. We get negative of 1 plus 0 to the -3/2 over 2a, which is -1 over 2a. Yay, we got something. Okay, so after all of that, remember what our original thing, like our original goal was. We were trying to set 1 equal to this limit. It turned out that this limit equals -1 over 2a. So what had we originally wanted? We wanted 1 to equal what we just found the limit is. And now we solve for a. So you multiply both sides by 2a, divide by 2. So you get that a is -1/2. And that's your answer for a. Any questions on this problem?
How did you know to switch the limit like in the very beginning because it's supposed to be like to infinity, so why is it to 0?
Yeah, because so you're thinking like x to infinity, but then why would they give you at 0? Like how could you, like you're gonna be using that somehow. And also, okay, say you didn't know this, which I also did not know, and you tried doing the limit as x goes to infinity and you set that equal to 1, right? You can work it out, multiply by the conjugate, simplify everything, nothing comes out. You're gonna get that the limit equals this. But then the degree of the numerator is 2, degree of the denominator is 3. That means that your limit is always 0. So you would never get it equal to 1. So this doesn't make sense. So you know that it must be, you have to do something else. So yeah, I also thought it was this way and I worked it out and couldn't get anywhere. So yeah. Any other questions on this problem? Okay, any other questions on fall 2020? So I know I didn't get 4. I'm sorry, don't know what economies of scale are. But yeah, remaining questions on fall 2020.
So was this an actual like administered final exam, like question 4? Could it be on our final exam this year?
Yeah, I think it was an actual administered exam. So I don't know what happened with this problem. Maybe they focused more on production stuff, but yeah, I'm not sure about this one. So you could, Rimmer has more office hours on Saturday, I think. So definitely ask about this question if people are unsure. All right, so then let's do spring 2018. Okay, since we don't have too much time left, let me take like questions that people want to look at if you guys did this exam. If not, then I'll just go over, pick random ones. But yeah, anyone have questions on this exam that you want me to go over? Yeah. Number 3. Okay. So number 3 says we want to find the constants such that the following functions are continuous. So whenever you see a question like this, okay, side question aside, if it asks where is f of x discontinuous, it's most likely going to be at like the endpoints of these intervals, like this 1 and this 5, because that's where different things are happening. Like at 1, it's defined with this first part. But then at 1 with an open circle, it's also defined at this part. So where it's discontinuous, your candidates would be at x equals 1 and 5. So that's where we want to make sure that they are continuous. How do we do that? So again, this is also the same So this is the same algorithm every time if you see this question. You should first think, okay, I'm gonna label these, like this first line is A, this second line is B, and the third line is C. What's the algorithm? You want at x equals 1 or at one of your discontinuities, where could 1 be defined? Well, we have one with like this A and one with this B. So we want x equal 1 plugged into A, plug in to A to equal if you plugged it into B. So if we plug 1 into A for x, we get 2A times 1 plus B. And if we plug in 1 to the second line, we get A times 1 squared plus 2. And we want those to be equal, right? So let's keep simplifying. So we have 2A plus B equals A plus 2. What if I subtract A on both sides? That gives me A equals, let me also subtract B on one side, negative B plus 2. So right now, this doesn't get us anywhere. We just have an equation, but this will be helpful when we do the next step. So even though you don't get an actual answer yet, it's fine. You have some expression that will be helpful. Then where's the other discontinuity? At x equals 5, where could 5 be discontinuous at? Well, it's here, there's something with B and something with C. So now we want to plug it into A, or B, sorry, and it should be equal to if you plugged it into C. So let's plug in x equals 5. We get A times 5 squared plus 2 equals, what happens when you plug it into C? You get B times 5 squared plus 27. So this gives you 25A plus 2 equals 25B plus 27. Or 25A equals 25B. I'm going to subtract 2 from both sides. So I get plus 25. Now, how is this helpful? We have two equations with different variables. But look at the first equation, the first blue one we got. We got that A equals negative B plus 2. So what if we substitute A into here? Let's substitute A here. So we get 25 times A is negative B plus 2 equals 25B plus 25. Now we can simplify. This gives negative 25B plus 50 equals 25B plus 25. Add 25B on both sides and subtract scalars. You get B equals 1/2. And now we got B equals 1/2. How do we get A? Using the same formula. So A we said was negative B plus 2. We just found that B is 1/2. Add 2. So this gives you 3/2. So the A is 3/2. B is 1/2. What was the question asking for? It was asking for A over B. So A over B is 3/2. You're dividing by a fraction, so multiply by the scalar. These cancel and give you 3. So the correct answer here is C, 3. Any questions on this problem? Or clarifications I can make? Okay. Someone in the chat wanted to know about 11. So, yes, the inscribed rectangle one. Okay, so inscribed rectangle. Let me first draw our nice purple rectangle. So it's asking us to find the largest area for this purple rectangle. What do we know? So optimizing, you know that it's already asking you for the largest possible area. That's a clue that you're going to be doing an optimization problem. It's going to involve derivatives. So you need some equation. But first, let's write down our givens. we're given that y equals e to negative 2x squared by here. They gave it to us. To do our rectangle, let me label stuff so that we can actually use them. So I'm gonna notice how they call this coordinate x comma y, and this is negative x comma y. So we can consider it as this blue length, this is x, right? Because that's the coordinate x. This other coordinate, that's if you go x backwards. So this is also x. So the whole length of our rectangle right now is 2x. The whole height of our rectangle, we're going to call y, because that's the coordinate. It went x over, y up. So what are we trying to maximize again? We're trying to maximize the area of our rectangle. Area is base times height. What is our base right now? It's 2x. And our height right now is y. But this is a problem because our equation is in terms of two variables. We don't want two variables. We want everything in terms of one variable, right? So how can we fix it? Well, we can fix it by saying area is 2x. What was y? They gave it to us. Y is this red thing, e to the negative 2x squared. So I'm plugging in y. So now our area is in terms of one variable. That's nice. That's what we wanted. Now the same algorithm. So these algorithms for optimization problems, write down your givens, what you're trying to maximize. Make sure it's all in terms of one variable, then critical points. So we want take derivative and find critical points. So what's the derivative of our area right now? Bless you. So you have two functions. Recognize that you need to use product rule. So derivative of our area, we write a prime of x is first term times derivative of second term. What is derivative of that? We need to use chain rule. So I wrote e to the same thing multiplied by the derivative of this complicated thing, which is negative 4x. Plus second term times derivative of first term, which is 2. Oh, I realized my color for this thing is green. Okay, but now how do we find critical points? We want to set this equal to 0, right? How do we do that? Remember a few minutes ago or half an hour ago or something, I said, oh, notice, you see an e to the thing and e to the thing here. We want to factor it so that we want something times something equals 0. That makes it easier on us. So let's factor that e to the negative 2x squared out. We're left with, here we have negative 8x squared plus, but all that's left here is 2. And so we want to set this equal to 0, which means we want this first thing equals 0, but that never happens. Oh. And then we want the second thing equal to 0, but that also never happens. Or sorry, not never happen. It does happen. Sorry. Okay, this never happens, but now this thing is what we care about. So if we subtract 2 on both sides, then divide by 8 on both sides, and square root, we get x equals plus minus 1/2. But remember, we don't want negative lengths, so just take the positive one, x equals 1/2. So we just found our critical point, x equals 1/2. Now, what was the original question asking for? Asking, oh, look at here. This one says, in the interest of time, you can skip the work proving that you had an absolute extreme value. That was the question that was asked a while ago. In this question, you could just find x, y, and the area. You wouldn't have to do the first derivative test or second derivative test. Okay, but it said find the largest possible area. We found x is 1/2. What is y? y is e to the negative 2x squared. So what is that? E to the negative 2 times a half squared, or e to the negative 2 times a fourth, or e to the negative a half. So our area is, what was our area? It was 2xy, or 2 times x times y, which is just e to the negative 1/2. So that's the largest, that's the area of the largest rectangle you can have inscribed under this parabola. And because the question said for the sake of time, you wouldn't have to do the check stuff. You can just stop here. Any questions on this problem? Okay, any other questions from this final? Yeah,
We go over 14.
yes, 14. Okay, yeah. All right, so evaluate the limit below. So let me get some more space. All right. So you see a limit question, limit of something plus something. Let's separate those first so that we can look at them separately. So limit of this first thing plus limit of this second thing. Okay. What? Oh, why? Sorry. Okay. What's the important? Okay, wait. Let me color these different colors so that looks nice. Okay. So we have the orange thing plus the purple thing. Let's focus on the orange thing. What does it mean for this sum of 1 to n of this? What does it mean to do? Like, what does this mean? It means you would have like k equals 1. What do you get when you plug in k equals 1? You get 6 over n squared. K equals 2. What does that mean? That means you have 6 times 2 over n squared, etc., etc. K equals n. What does that give you? It gives you 6n over n squared. Okay, but notice that each time, no matter what term you have, so you would technically be adding all these together, but no matter what term you have, you always have this n squared under here. That's because the n squared never changes. What your counter variable is, your counter right now is k, because you're plugging different numbers into k. So right now, this n squared, like it always stays the same no matter what. So you can rewrite it by taking this 6 over n squared. So I'm going to take the 6 over n squared and take it out. It's basically acting as a scalar. We don't really need
We can't hear you.
that formula. So, okay, let me screen share. Okay, can people hear me now? Wait. Okay, but this is not loading. Okay, so wait, it's not moving my changes. Oh, okay. Nice. Okay. Now, this summation from yesterday's review session, we know the formula for that summation. What is the formula for that summation? Let's look it up. So, Where did I write it? Somewhere in here. Here. What is the sum of 1 to n of k? Because you're doing 1 plus 2 plus 3 plus 4, etc. It's always going to be this formula. How many terms you have times how many terms you plus 1 over 2. So it's n times n plus 1 over 2. So we have n times n plus 1 over 2. Let's check to make sure how many terms do we have. To figure out how many terms we have, we do what's the largest number, n, minus what's your first number, 1, plus 1. So yes, it is n. We can keep this as our formula for this orange sum. Oh, let me use different color. Okay, so we just found the orange one. What about the purple one? So the purple one, we can do the same thing. This 30 over n squared, it's acting like a scalar. It's always going to be there for all of your terms. So let's move that out. Let's move out the 30 over n cubed and just do the sum from k equals 1 of n of k squared. What is this sum? It's also in that chart. So we have, this is n cubed of, so the formula in the chart will say it's n times n plus 1 over 2n plus 1 over 6. So this is what we have right now. Now you can remember, what are our limit rules as n goes to infinity? Those are where you look at the degree of the numerator and the denominator, right? Right now, the degree of our numerator is n squared, so degree 2. The bottom is also n squared. So what do you do in that case? You take the coefficients, which is 6 over 2. This first one gives you 6 over 2. What about the second one? You get an n cubed in the top and an n cubed in the bottom, same degree, take their coefficients. We have a 30 and a 6. So this is plus 30 over 6. Or it's 3 plus 5, which is 8. The correct answer here is D. Yeah. Why we're taking the limit, you said? Or sorry.
Like, why do we just ignore the whole?
Oh, yeah. Okay, so it's because, so what I wrote here, so what does it mean to do this sum? Like, what is this summation saying? It's saying you look at the k equals 1 term and see what expression you get. For the k equals 1 term, if you plug in k here, you get 6 times 1 over n squared. Then you look at the k equals 2 term and you plug k into here. You get 6 times 2 over n squared. And you would keep seeing what each of these terms are, k equals 4, etc. And the summation is telling you, for each k, find the expression, add up all those expressions. But notice that for each expression, like you always have this 6 over n squared, no matter what. So we can just focus on finding the sum of this k. Because, so here, if we took out this scalar, so 6 over n squared times the summation of k, what would this be saying? This would be saying you're doing 6 over n squared times this orange summation. This orange summation is telling you when k equals 1, it's 1. When k equals 2, it's 2, etc. When k equals n, it equals to n. And then if you factor these out, you get exactly this simplified. Like you get 6 over n squared times 1, which is exactly that term. Then plus 6 times 2 over n squared. That's exactly the second term. So it's just a different way of writing it so that we can better simplify what this actually means. Any other questions on part A?
I have a question.
Yeah.
Can you explain the coefficient part when you took the 6 and the 2 and the 30 and the 6?
Yes. So what are the rules for a limit as your variable goes to infinity? You look at the degree of your numerator and degree of your denominator. If the degree of your numerator is less than the degree of your denominator, that means your limit is 0. If they were equal, then that means your limit is their coefficients. If the degree of numerator was greater than degree of denominator, then your limit does not exist. So here, the degree of our numerator is 2. Degree of num equals 2. Our degree of denominator also equals 2. So what does that mean? We take the limit equals their coefficients. The coefficient on the top is a 6. The coefficient on the bottom is a 2. So your limit is the coefficients, 6 over 2, which is 3. And you do the same thing for the Okay, any other? Yeah. Yes, only for infinity. This is only the rule for infinity. If you have n going to like a number, the first thing you always want to try is you plug in that number first. And then if it doesn't work, you have all those other techniques. Yeah. Yeah. If there's like, if you just had this and then like another cosine x on the top, whatever, you can still just focus on the n squared part. The n squared, it'd still be 3. Okay, any other questions on part 8? Okay, part B. So part B is find, okay, this is a question. Does anyone want to guess what I'm about to say? Using what rule? Yes, great. Yeah, so this is fundamental theorem of calculus, part 1, which someone also asked about yesterday. So what does this mean? You're doing first without the 1. Let's just figure out what is g prime of x. G of x is this integral. So g prime of x means you're taking the derivative of this. So this is the derivative of the integral they gave us. Now, what did I say the rule for fundamental theorem of calculus was? If you're doing the derivative of, let's see, like some number to g of x of f of x, derivative, wait, let me do the same variable so it looks the same. Like this dt. Then you plug in whatever upper bound this is into your function. So we plug in g of t. But if this g of t is not something as simple as a single variable, you have to multiply by the derivative of that bound, by similar to like a chain rule. So what does this mean for our answer? This function, we plug in square root x wherever we see a variable, wherever we see a t. So I'm going to write 4 over square root 3. Oh, I see a t there. Let me plug in square root x squared plus 1. But then you want to also be careful to multiply. You have to multiply by the derivative of square root x. What is the derivative of square root x, or 1/2? That's 1/2 x to the negative 1/2. So 1/2 x to negative 1/2. Now, what was the question asking for? It was asking for g prime of 1. So let's plug in numbers. Get 4 over square root 3 times 1 plus 1 times 1/2 times 1, which is 4 over square root 4 times 1/2, or 4 over 2 times 1/2, which is 1. So the correct answer is A. Any questions on part B?
So do you just
So,
recognize that you have to use the fundamental theorem?
Yes, because okay, if you didn't recognize that it was the fundamental theorem of calculus, you would have to take this integral. But how do you take this integral? You get stuck, right? Because you might maybe use substitution, like u equals 3t squared plus 1. But then your derivative is 6t. we don't have any t's left over here. How do we plug that in? If you think about integration by parts, well, that also doesn't help us out too much because you're going to be having to take the derivative and integral of something no matter what. So yeah, this like would be very hard to compute if you didn't recognize fundamental theorem of calculus. There would, if this was an easier integral, then yeah, you could take the integral of this, then take the derivative of that, and you should get the same answer. But because this is more difficult, the question was about recognizing this rule. Okay, did someone on Zoom have a question? I heard something.
Yeah, so the lower bound doesn't matter.
Yes, lower bound doesn't matter. It just has to be some number. Has to be a number though, but it can be any number.
Does it ever happen that the g of t is on the lower bound and then the upper bound is just a number? And then do you just use the formula where you flip the?
Yes.
Okay.
Yes, use the formula where you flip. So it become negative of flip the bounds, same thing. Any? Yeah, so what she was saying was if you were given like number g of t of f of t dt dx, this is, you can do negative of, now you can flip the bound so that the number's on the bottom. F of t dt.
You just multiply the f of g of t times g prime of t by negative 1 at the end.
Yes, so here there's a negative here. Yes. So you would evaluate this normally and then everything times this negative 1. Okay, any other questions on part B or this question?
Wait, so then if it ended up like, let's say it was the bottom part, right? Negative, would it just end up being like a negative version of what we got?
Yes. So it'd be negative 1. Any other questions on part B? Okay, other questions on this exam? Wait, let me ask Jessica. Yeah. Okay. All right, do you want to tell me what's your first thought on this problem?
So on my like cheat sheet kind of list,
Mhm.
I saw that the integral of cos.
Uh-huh.
Yeah, that's e to the x plus e to the negative x over 2. So, and when I looked at this, I thought of doing like tabular integration.
Okay. Wait, let me tabular. Yeah, that could work. Okay. So, but I just want to say on your cheat sheet, this, oh, you said cosh equals this, right? Not integral of cosh equals that.
Right.
Okay, just to make sure. Integral of cosh is sinh x. Okay, so you're suggesting tabular integration. So let's try that. We start on the left side with 8x, take the derivative, 8, 0. That's nice. So this was the derivative side. On the integral side, we have cosh of x squared. How do we take the integral of that? So let me do a little side note. What is integral of cosh x squared dx? So let me, it would, I think it's 4, but let me write it out. So you have u substitution, right? U equals x squared, or wait, yeah, sorry, it might be 2. Okay, du equals 2x dx. So 1/2 du equals, oh, wait a second. So you encountered a problem, right? Because you have an x dx. We don't have any leftover x's in our integral. But now you notice something. We have an x left over if we use like u equals x squared. Look at the original problem. we have an x here in our original problem. So if we forget about integration by parts, let's just focus on this integral. If we choose u equals x squared, du equals 2x dx, what is left remaining? We need an 8x dx. So let's make this 4 du equals 8x dx. Now we can do u substitution. So we have this integral of what is our u? Or wait, sorry, we're doing cosh of x squared is our u. And we were left with 8x dx, which we found is 4 du. So you see how you encountered a problem, but we saw that there was a leftover x here. So that might have been helpful in our original problem. Okay, so now we have this integral. Let me move the 4 out again because I don't like scalars. So we have integral of cosh u du. What is integral of cosh? It's sinh. So we have 4 times sinh of u evaluated at those bounds. What was u? Because remember, we don't want u's in there. So we have sinh of u was x squared evaluated at these bounds. Okay, but now you get stuck again. Because how do you look at all their answers, their numbers. What even is sinh of 0? Well, there were the formulas, which I did not add in my like trig sheet, but maybe you should add it, that sinh x equals e to the x minus e to the negative x over 2. And there's also formulas for cosh and tanh, which you can, or I'll just write it here, I guess. So this minus negative x over. Okay, so now we can, what is sinh of x squared? So we have plug in square root of natural log 2. That gives us sinh of ln2 minus plug in 0. So that's sinh of 0. What is sinh of natural log 2? Let's follow the formula. That tells us that it's e to natural log 2 minus e to the negative natural log 2 over 2. Then minus, what do we do? Plug in 0. We get e to the 0 minus e to the 0 over 2. So we get 4 times, what is e to the natural log 2? That's 2. Minus, be careful about when you're simplifying this, e to negative natural log 2. That is 2 to the negative 1. Because you move the natural log next to the e. So it becomes e to the natural log 2 to the negative 1. So it's 2 to the negative 1 over 2 minus, this is 1 minus 1 over 2. So we get 4 times 2 minus a half over 2 minus 0. Or we get 2 times, this is 3 halves, or 3. So the correct answer here was C, 3. Any questions on this problem?
So just definitely write the sign H, because H.
Yeah, just in case. It asks you to like evaluate it. Yeah.
So we substituted natural log of 2 instead of natural.
So we substituted radical natural log 2 for x, but then that becomes squared. So natural log 2 squared. Yeah, so the square and the square root cancel. So I just wrote natural log x. And then the 0 is 0. Squared is 0.
Can you explain the negative e to the negative ln2 again? Like that part, how it becomes 2 to the
Yes.
negative 1?
So let me write in purple here, e to negative natural log 2. Whenever you're simplifying that, you should always have the e and the natural log right next to each other. So this would be, let me imagine this is like -1 times natural log 2. When you're multiplying in your like exponent, it's okay to switch them up because multiplication is commutative or associative, whatever. So that becomes like that. You want the natural log right next to e. So this is e to the natural log 2 to the -1 in that exponent. Then what is e to the natural log 2? That's 2 to the -1. So it's 1/2. Any other questions on this problem? Okay, other questions on the exam then? Yeah. All right, number 10. Oh yeah, okay. So this one was also weird. Okay, so the first thing you see is we have this cosine x to the 3/x². That's odd. So can we simplify anything? There's nothing standing out right now. Can we use substitution? Well, what might we choose for you? Maybe say we choose this weird exponent, but then our du would also have like an x or something in it. There's nothing left over. Wait, what am I doing? Sorry. I'm thinking of integral. Ignore that. We have limit of this. First thing we do is plug in 0. So cosine x of 3/x². Plug in 0, but if you plug in 0, you get divide by 0 error. You can't do 3/0. So we need another way to write this limit. In previous questions, maybe we would have done, or this was involved in like finding like how many digits did a number have? Or like those related questions. Remember what we did there? We would do 10 to the natural or to the log of whatever thing they were asking us to find. So we're going to use a similar technique here, but here we're going to use the technique where e to the natural log of whatever they're asking us to find. E to the natural log of this thing that we're asked to find. Because doing e to the natural log by the inverse property rule, e to the natural log of this is just what's in here. So we know that e to the natural log of that equals this thing. They're equivalent. You're just writing it differently. How does that help us? Well, natural log is good for us because natural log, there's a bunch of rules that we can simplify things, which is why we thought of why you would want to think of natural log in the first place. So how could we write this exponent here? Well, we have natural log and this exponent 3. Natural log rules say we can bring this down. So we have 3/x² times natural log of cosine x. And then another rule, which wasn't stated very often, but it's that the limit of a composition equals the composition of the limits. Meaning if you have limit of like an f of g of x, that equals f of the limit of g of x. So in this case, we can move this limit. We're going to do e of, we're going to move this limit to here. Limit of this 3/x² natural log cosine x. So right now we have limit. Let's focus on this limit, we have limit of 3 natural log cosine x over x squared. This looks like a promising thing. But we plug in 0. How do you do this? You plug in 0, right? You would get 0 over 0. So plug in 0, get 0 over 0. So you want to use L'Hopital's rule. So this becomes limit derivative of 3 natural log cosine x. That's the derivative of your inner function, which is negative sine x, over your original thing, which is cosine x. And we have that 3 out there, of course. What is derivative of x squared? It's 2x. So now we come into using their hint. Their hint said tangent was sine over cosine. Right now we have sine over cosine, so let's use their hint. Sine over cosine is tangent of x over 2x. Okay, but then you plug in 0 again. So plug in 0. You get 0 over 0 again. Yeah.
Is it negative 10?
Oh, yes. Negative sign. Negative. Yes. Thank you. So now we plug in 0. We get 0 over 0 again. Use L'Hopital's rule again. So we get e to the limit of, what's the derivative of tangent? That's, so we have negative 3. Derivative of tangent is secant squared x. Derivative of 2x is 2. Okay, so now let's try plugging it in. What is secant squared of 0? Secant, remember, is 1 over cosine squared x, because secant is 1 over cosine by fact. So now you have secant squared is just cosine of squared of 0. What is cosine of 0? We know that's 1. So that's 1 over 1 or 1. So now this gives you, we just found the limit of the top is 1 over 2. Wait, sorry, 3 over 2. Negative 3 times 1 over 2. So e to the negative 3 halves. So the correct answer was B. Okay, any questions on this problem?
I have a question.
Yeah.
So when we were taking when we did L'Hopital's rule and we took the derivative, right?
Mhm.
I know that you have to, like for cosine, it becomes sine, but why did we put it under the, why did we put it, because I know you have to like take the derivative of like what's inside, right?
Yes, yes.
Can you explain that again, that part?
Yeah. So that's by chain rule. So the derivative of natural log of some u, some complicated u, by definition, it's you do the derivative of your outer function, which would technically 1 over u. But because this u is complicated, you have to multiply by the derivative of that u. So what does that mean for derivative of cosine? That means we're going to do 1 over cosine times, what is the derivative of cosine? It's negative sine. That's how we get that.
Oh, okay. Thank you.
Yep. All right. Any last minute questions before we end? All right. Let me end the recording.